Bismillahirrahmanirrahim. This is the next topic, that is the states of matter. So I think we are all reasonably familiar with the three states of matter in our everyday world. So at a very high temperatures, you get the fourth state. But the three ones that we normally deal with are things which could be solid or liquid, or it could be a gas. We have this general notion, and I think water is the example that always comes to at least my mind. Water. Okay, so when we move to the states of matter, when we talk about the states of matter, so we have total four states of matter. Number one is solid, number two is liquid, number three is gas, and number four is plasma. Right? So these three are the normal. Let me get my pen. Um, these three are the normal one. Okay, so you can observe in water. Water key, we have water in three different states. You know this thing. Okay, so water is always present in three different states. Ice, okay, and liquid water and steam, right? Now, if we increase the temperatures, there is the fourth state, which is known as plasma. So this plasma we usually get at a very high temperatures, right? So next we go to slide number 3. So first I will explain this a little bit. So the point is that what is actually happened, that these three states are interconvertible. So we need to understand this point very carefully. So for example, if I write ice, okay, if I write ice, ice is the solid state. You know, ice is the solid state. Let me get it. So this is the solid. So when it is converted by the absorption of amount of heat, it is converted into liquid. This is how the states are interconvertible. Okay, so this is now liquid. Again, when it absorbs some amount of heat, it will become gas. Right? So this ice, this is called actually liquid water. The water which we are having, this is actually known as liquid water. Right? And this is the gas, and we are familiar as a steam. Okay, guys? So what's actually this is colder. Okay, so this state is colder. This state is colder. This is warm. And gas is hot. These are the three states of matter which are interconvertible. So you go from colder to hotter. When you go from colder to hotter, you get three states, and so on. So when you go from hotter to colder, again you will get the three states. Now we come to states of matter. So these three different states, solid, liquid, and gas, these are based upon three assumptions. Number one, particle arrangement. Number two, energy of particles. And number three, distance between the particles. So if we see, say, if this is the solid, okay, this is solid, this is liquid, and this is gas, right? So you see that they are tightly packed over here. They have some little spaces, and these there is a lot of spaces. Okay, the distance among the particles is too large, less, and least. So here the distance among the particles is too large. बहुत ज़्यादा है इधर distance. Large. Here it is less, and there is no distance among the particles. So that's why we can say that solids, they have definite shape and definite volume. Liquids, they have definite volume but no definite shape. They will get the shape of the container in which they are, and gases, they have neither shape nor they have any volume. So the three states of matter are solid, liquid, and gas. So if we talk about the particle arrangement, if we talk about with this, if we talk about explain the states of matter on the basis of particle arrangement, the particle model represents particles by small solid spheres. Here you can see it, right? Here you can see this particles, okay? It describes the arrangement, movement, and energy of particles in a substance. We call the particle theory of matter, which is known as kinetic molecular theory. In the upcoming slide, I will give you some information. So the particle theory of matter actually describes the arrangement and movement of particles in a substance. So if we talk about what is the most important thing, that is the energy. So all particles have energy. Remember, all particles have energy, but the energy varies depending on the temperature, the sample of matter in it. अब जो सैंपल है उसका उसकी जो एनर्जी है, उसका जो टेम्परेचर है, ठीक है, दैट काउंट्स एक्चुअली. So if I say okay, the sample of this in turn determines whether the substance exists in the solid, liquid, or gaseous state. So please guys understand this point, which is very important, that all particles have energy, but the energy varies depending on the temperature, depending upon the temperature. अगर temperature high है तो energies high होंगी and vice versa. टेम्परेचर मॉडरेट तो एनर्जीज जो पार्टिकल्स की जो एनर्जी होगी वो मॉडरेट होगी, एंड इफ टेम्परेचर इज टू हाई तो पार्टिकल्स के दरमियान जो एनर्जी भी है दैट इज टू हाई. सो solid, liquid, or gaseous states are due to the energy differences, or energy differences are due to temperature differences. Molecules in the solid phase have the least amount of energy, while the gas particles have the greatest amount of energy. Again, this is due to the temperature. Solid चीज का temperature कम होता है, negligible होता है, और gaseous का temperature बहुत high होता है. Second important factor, which is very important, that is the distance among the particles. So gases consist of very large number of tiny sphere particles that are far apart from one another, okay, as compared to their size. So distance between particles of a gas is highly greater than the solid and liquid. So what's the main thing? The main thing is that we have concluded that if we want to explain on the basis of particle, on the basis of energy, and on the basis of distance. So these are the three important factors, okay, which are responsible for the shape of matter: particle, okay, energy, and distance. Now we move to the next slide. Here you can see, so ये before है. Now red line means, these arrow means we are increasing temperature, and these arrows means that we are decreasing temperatures. So when you increase the temperature, this is solid, this is liquid, and this is gases. So when we increase the temperature of solid, okay, it is converted into liquid, and when we further increase the temperature, it is converted into gaseous state. So before this is the arrangement, and after the increase of temperature, you can see the random distribution of particles. So when we decrease the temperature, okay, so again we go to liquid and then we go to solid, right? Now we come to the kinetic theory of matter. So kinetic theory of matter actually explains the exclusively for gaseous molecules. So matter is made of particles which are in continual random motion, and the motion is like this. This is you can see that this is the particle, these are particles, these are particles, right? So we need to understand what is the kinetic theory of matter. So kinetic theory of matter states that the gas particles are in constant state, in a constant motion, and exhibit perfectly elastic collisions. Okay, the average kinetic energy of a collection of gas particles is directly proportional to the temperature. If you increase the temperature, you increase the energy, right? So next slide, we go to next slide. That is three main components to kinetic theory. Number one, no energy is no energy is gained and lost during when molecules collide. Perfect elastic collisions. Okay. Number two, the molecules in a gas take up negligible amount of space in relation to the container they occupy. And number three, the molecules are in constant linear motion. Okay, so linear motion. So these are the three main components to kinetic theory. Now let's have the last look on the states of matter and the particles, their position and their movement. So we can say that the particles of solids are tightly packed, vibrating. You can see the vibration, but this vibration is about a fixed position. ये fixed position पे है. So that's why solids have a definite shape, a definite volume. Next, liquid states of matter. Now here you can see the particles of liquid are tightly packed but are far enough apart to slide over one another. Here you can see, okay? और ये कब होता है जब आप heat provide करते हैं. So liquids have an indefinite shape but a definite volume due to this. Next, gases. Now you can see the gases when you provide the heat. You can see that they elastic collisions. You can notice the elastic collision. This is the elastic collision. Yes, again. So particles of gases are very far apart and move freely. Okay, so gases have an indefinite shape and indefinite volume. Now we come to some physical changes, right? So description of the phase change. Solid to liquid में when you go, the process change is known as melting, or heat goes into the solid as it melts. So इसमें heat absorb हो रही है in the solids. So when you go from liquid to solid, the process is known as freezing. So heat जो है वो leaves the liquid as it freezes. It gives out the heat. Next, liquid जब gas में convert होता है, liquid when it is converted into gas, तो चेंज क्या होता है? वेपोराइजेशन होती है, विच इंक्लूड्स बॉइलिंग एंड एवेपोरेशन, ये दोनों प्रोसेसेस हैं, ये चेंज है. सो हीट गोज इनटू द लिक्विड एज इट वेपोराइजेस, अगेन द हीट इज बीइंग एब्सॉर्ब. जब गैस लिक्विड में हो रही है तो इसे कहते हैं कंडेंसेशन. Gas, when it is converted into liquid, it is known as condensation. Actually, heat leaves the gas as it condenses. The heat is given off. Then we go to solid to gas, that is known as sublimation. When solid directly converted into gas, it is known as sublimation. So heat goes into the solid as it sublimes. So these are the physical change, phase change, term of phase change. You have to be very particular about the term for phase change and heat movement during phase change. आपको heat की movement भी पता चलनी चाहिए, क्योंकि आइदर तो रिएक्शंस जो होते हैं वो एंडोथर्मिक होती हैं और एक्सोथर्मिक. तो जब हीट एब्जॉर्ब होती है तो रिएक्शन इज एंडोथर्मिक, और जब हीट गिवन ऑफ होती है तो वो एक्सोथर्मिक होती है. बट व्हाट हैपन्स, very important question, but what happens if you raise the temperature to super high levels between 1000 degrees centigrade and this? Will just everything just be a gas? No, it is not the gas. Here we can have the fourth states of matter, which is known as plasma. So plasma is an ionized gas. Ionized gas का मतलब होता है कि जो particles होते हैं वो charged हो जाते हैं, पॉजिटिव चार्ज या नेगेटिव चार्ज, चार्ज्ड हो जाते हैं. ठीक है. A plasma is a very good conductor of electricity and is affected by magnetic fields. So plasma, like gases, have an indefinite shape and indefinite volume. Plasma is the common state of matter, or you are familiar with this terminology. Now states of matter कि अगर हमने स्टैटिस्टिक्स देनी है या फ्लो शीट डायग्राम देनी है तो आप ये दे सकते हैं कि each addition of energy creates a change in state. For example, solids हैं, solids में आपने you have added energy, it is converted into liquid. Again, when you added energy, it is converted into gases. Again, when you added this energy, you go to plasma. And this is the animation. Solid, this is solid, this is liquid, okay, this is gas, and this is plasma, right? So solid, liquid, and gases. Again, the definition is totally packed in, you can read because I have already explained to you. Some places where plasmas are found. Number 1, flames. Number 2, lightning. Number 3, aurora, northern lights. Number 4, the sun is an example of a star in its plasma state. And number 5, these are the plasma different states. You can study them, right? Cold plasma. This is the cold plasma. So this is all about this lecture. और इसकी जो continuity है, I will go to the next lecture. We can see them more deeply. Thank you so much.